deep in the equatorial rainforests of Africa, where the dense canopy shelters secrets both ancient and modern. A silent killer once stirred from the shadows. It would soon earn a name that evoked fear across the globe: Ebola, with sudden, horrifying symptoms and fatality rates that reached as high as 90%. Ebola was a virus that shocked the world each time it surfaced. But where did this deadly disease come from? How did it make the leap from the heart of the jungle to bustling cities and hospital wards? Today, we take a journey through time and terrain to uncover the mysterious and terrifying origin of the Ebola virus, a microscopic invader with a massive impact. From remote African villages to cutting-edge laboratories, from fruit bats to international outbreaks. This is the story of one of the deadliest viruses known to humankind. Ebola virus disease, or EVD, is a severe and often fatal illness that affects humans and other primates. The symptoms are sudden and brutal: fever, headache, muscle pain, followed by vomiting, diarrhea, and internal and external bleeding. Death can occur within days due to organ failure and shock. Ebola is caused by a virus from the Filaviridae family. Under an electron microscope, it appears as long, thread-like structures, some curling into mysterious, snake-like shapes. It's classified as a biosafety level 4 pathogen, the highest level of danger known to science. There are 6 known species of Ebola virus, but the most deadly is Zaire Ebola virus, named after the region where it was first identified. The virus spreads through direct contact with bodily fluids: blood, vomit, urine, or sweat of an infected person or animal. Once inside the body, Ebola hijacks the immune system, spreading chaos at cellular and systemic levels. Unlike respiratory viruses like the flu or COVID-19, Ebola isn't airborne, but its terrifying lethality makes even limited outbreaks catastrophic. In some outbreaks, up to 9 out of 10 infected people die. Before we understood Ebola's devastation, we had to meet it for the first time. That moment came in 1976, sent to distant villages in Central Africa, forever changing the world's view of viral disease. In late August 1976, in the village of Yambuku, the northern region of what was then Zaire, now the Democratic Republic of the Congo. Schoolteacher named Mabalo Lakila returned home from a trip near the Sudanese border. He felt feverish, weak, and nauseated. Thinking it was malaria, he visited the local missionary hospital. He received an injection of chloroquine with a reused syringe, a common practice at the time due to lack of medical supplies. What no one realized then was that this single injection had likely sealed the fate of dozens of people. Lakala's condition rapidly deteriorated. He developed bloody diarrhea, uncontrollable vomiting, and bleeding from his nose and mouth. He died soon after. But by then, the virus had already begun its lethal march. Within days, patients and hospital staff began falling ill with identical symptoms. Panic spread through Yambuku. The virus seemed to leap from person to person with terrifying speed. Belgian nuns who ran the hospital were among the victims. Their deaths drew international attention. The World Health Organization and the Centers for Disease Control were called in. Virologists and epidemiologists arrived in Yambuku wearing protective suits that would later become iconic in images of viral containment. Samples sent to Europe and the US revealed a new, previously unidentified virus. Because the outbreak was near the Ebola River, scientists named it the Ebola virus. At least 318 people were infected in that first outbreak. 280 died, an astounding 88% fatality rate. The virus vanished as quickly as it came, burning out when there were no more people left to infect. But Ebola had made its introduction, and it wasn't the only time it would rise from the jungle. Strangely, at nearly the same time as the Yambuku outbreak, another cluster of Ebola cases emerged, 1,000 kilometers away: Nzara, Sudan. In June 1976, workers at a cotton factory fell ill with similar symptoms: fever, vomiting, internal bleeding. Investigators discovered that the Sudan outbreak started independently from the Zaire outbreak. But the virus was closely related. Scientists named it Sudan Ebola virus, less lethal cousin of the Zaire strain, with a case fatality rate around 50%. This eerie coincidence, two outbreaks of similar viruses in different countries at the same time, was a shocking revelation. It raised disturbing questions. Was the Ebola virus already circulating in the environment? Could there be multiple sources? Was there a hidden reservoir where this virus lay dormant, waiting to strike? These questions triggered an urgent hunt for Ebola's origin. To understand where Ebola comes from, scientists needed to identify its natural reservoir, the animal species that hosts the virus, without becoming sick. This reservoir allows the virus to persist in the wild between human outbreaks. Initial theories blamed everything from monkeys to insects to forest pigs. But there was little concrete evidence until researchers began to focus on bats. In particular, fruit bats of the Pteropodidae family became prime suspects. These bats live in tropical rainforests and have large geographic ranges across Africa. They are also hunted and consumed as bushmeat in many rural communities. Studies found that some species, such as the Hypsognathus monstrosus, Epomops franketti, and Myonicterus torquata, carried antibodies and RNA fragments linked to Ebola. Crucially, these bats didn't show signs of illness when infected, perfect conditions for a natural reservoir. The theory became more convincing, as many Ebola outbreaks were traced back to human contact with infected animals, including chimpanzees, dewakers, and bats, softened during hunting or food preparation. Though definitive proof remains elusive, the bat reservoir hypothesis is now widely accepted. But how does the virus jump from bat to human? Often it's through what's called spillover events, when humans enter bat habitats, handle bat carcasses, or eat bushmeat. It's a tragic interaction of ecology, survival, and infectious disease. Ebola doesn't arise randomly. Its outbreaks are driven by a mix of environmental and human factors. Deforestation, mining, urban expansion, and agriculture push humans deeper into forests where bats live. As we disturb natural ecosystems, we increase the chance of zoonotic spillover. In Africa, subsistence hunting is vital for survival, and bushmeat is a major source of protein. But handling and consuming wild animals, especially bats and primates, increases the risk of exposure. In many Ebola outbreaks, the first human case, called the index case, has been linked to such contact. In 2007, a boy in the Democratic Republic of the Congo fell ill after handling a dead monkey. In the 2014 West African outbreak, the suspected index case was a 2-year-old in Guinea who played in a bat-inhabited tree. As villages become connected by roadways and global travel, viruses that once stayed isolated can now spread quickly across borders, leading to urban outbreaks and global panic. Ebola is no longer just a jungle virus, it's a global health concern. In December 2013, in a remote Guinean village called Meliandou, a toddler named Emile Wamuno fell ill. He had a fever, diarrhea, and vomiting. He died within days. Soon, his sister, mother, and grandmother became sick. The virus spread to nearby villages and towns. What followed was the largest Ebola outbreak in human history. From Guinea, the virus moved to Sierra Leone and Liberia, nations with fragile healthcare systems still recovering from civil wars. Urban centers like Monrovia and Freetown became viral hotspots. In some communities, corpses were left in the streets, and entire neighborhoods were quarantined. The outbreak overwhelmed hospitals, killed thousands of healthcare workers, and sparked global fear. Cultural practices like washing the bodies of the dead became vectors for viral spread. By the time the epidemic ended in 2016, more than 28,000 people had been infected. 11,000 died. It was a wake-up call to the world. This time, the virus was not the Zaire strain, but a closely related variant. It showed that Ebola could mutate, adapt, and travel far from its forest origin. Scientists rushed to develop vaccines and experimental treatments. global health organizations revised their emergency response playbooks. The world had seen the face of Ebola and knew it could strike again. For decades, Ebola was seen as too rare to justify expensive vaccine development. But the West African epidemic changed that. Pharmaceutical companies, researchers, and governments raced to develop a vaccine. By 2019, a breakthrough had arrived. Arvesvisabov, a vaccine that provides immunity against the Zaire Ebola strain. It was tested during outbreaks in the Democratic Republic of the Congo and proved highly effective. Other treatments, like monoclonal antibodies and antiviral drugs, have also been developed. Survivors can donate blood rich in antibodies to help current patients. Today, ring vaccination strategies, where health workers vaccinate people who VE had contact with an Ebola case, help contain new outbreaks swiftly. While challenges remain, science has made remarkable progress in turning Ebola from a mysterious killer to a manageable threat. The story of Ebola is a cautionary tale. It reminds us that human health is inseparable from the health of animals and the environment. When we clear forests, traffic, wildlife, and ignore sanitation, we invite ancient pathogens into the modern world. It also teaches us humility. In the 1970s, Ebola was an obscure curiosity. In 2014, it was a global crisis. Tomorrow, another virus could follow the same path. We've learned that preparedness matters, that community education, protective equipment, and early detection save lives. That culture must be respected, even in crisis. And that trust between public health workers and local communities is essential. Most of all, Ebola teaches us that even in remote corners of the world, what happens to one human being can ripple across the globe. We are all connected in health, in danger, and in responsibility. Ebola, once a mysterious and deadly virus lurking in the heart of the African jungle, is now a symbol of both fear and progress. It has killed tens of thousands, devastated communities, and exposed the weaknesses in global health systems. But it has also inspired innovation, solidarity, and resilience. The origin of Ebola remains partly shrouded in the canopy of Central Africa. But every outbreak brings us closer to understanding and controlling it. As long as we remain vigilant, ethical, and united in the face of viral threats, we can hope for a future where Ebola and diseases like it no longer hold the world hostage. Because the jungle may never be silent, but humanity has learned to listen.